Guys, always remember what is an IP address. Okay, what is an IP address? IP address is a logical address, and MAC address is a physical address. Okay, so MAC address on any NIC, there is only one MAC address. Means you have one NIC, means one MAC address. Okay, you have one NIC, you have a one single interface card is there. So it is has one MAC address only. And this MAC address is given by the manufacturer of NIC. So okay, and this is IP address is a logical address. Of course, on TCP IP layer means in the network layer we assign an IP address, right? So this is a logical address. It is assigned by user or by DHCP server, means it will be assigned automatically, or you have to assign to your PC manually. So that is a changeable IP address. It's a logical address. Why it is called logical address? Because it is based on your network. Based on what is your network, based on your network, we will configure the IP address. So there is a change of network. Like for example, I have an IP address like this. Okay, if I go to my hometown, then my IP address may change. If I go to not only physical location, because it's like a what network is using in that location, based on that I will get an IP address. So IP address is logically assigned or logically given based on the planning of network. Okay, number of PCs in the network, like that. Okay, it's a logical address. MAC address is a physical address. MAC address is on NIC permanently. It is assigned. We cannot change it, but we can change an IP address if you whenever we based on the network. Okay, in IP address we have a public IP, private IP addresses are there, but in a MAC address we don't have any private and public kind of stuff. It is fixed address. Okay, IP address is used for communication, so we use IP address for a communication purpose. MAC address we use in the communication, but we cannot communicate with the MAC address. Remember guys, we don't use in a communicate. It's not point that is wrong actually. Okay, so that is absolutely wrong, but important is always remember we communicate with IP address. We can't communicate with MAC address. Okay. Like you want to send a ping. Want to ping to other PC. What we are using IP address only. We are not pinging with MAC address. We are not request a web page from the web server using a MAC address. Okay, I want a web page. You are not asking to that one. So you are using an IP address for any communication. So it is always remember, guys, all communications by IP address only. You have to use an IP address for any communication. You cannot communicate with the MAC address. MAC address is a physical address, because the difference between IP address and MAC address is also very important. Next, IP address is a logical address. The definition of IP address is uniquely identify a device in the network. You know, lot of people try to read once and remember off and speak only this part. Okay, so unique address, some people say when we given this statement, people will tell answer like this: IP address is a unique address. No, guys. IP address is not a unique address. It is uniquely identify a device in the network. Depends upon the network. Okay. Each device will be based on the network. Each device will be identified uniquely. See it is. I'm using a 10.0.0.11. 10.0.0.12, 10.0.0.13, 10.0.0.14. So what is the unique part here? It is the 11, 12, 13, 14. Okay. So this is a very similar point. So this is a roll number sequence, or maybe a apartment sequence. You can say like this. Okay. See, 4 is common for all these things. Okay. 4 is common. 1, 2, 3, 4. For example, you take as a roll numbers: 401, 402, 403, 404, 405, and there is a 406. But in between there is 303 is there. It is a different from this. This is different again from this 4 series, right? So it is similar kind of stuff. There is another explanation is also there. Morning I given good explanation. But okay. So like a roll numbers, pin numbers and all. So you follow a sequence under here. Okay, that's it is uniquely identified. Guys, always remember we use TCP IP protocol suite, not IPX, SPX or AppleTalk. We use TCP IP protocol suite. Okay, and we use maximum star topologies only. So this is the star topology. We use star topologies only, not a mesh topology, ring or a bus topologies. Next, we have a two type of IP addresses: IPv4 and IPv6. There is no IPv5, not in the market at least. Okay, IPv4 and IPv6, and we are mainly using IPv4 only. Okay, main communication, all communications by IPv4 address only. IPv6 used by certain countries and certain private organizations only, not enter globally. Completely using IPv6 is not came, including the very big countries like America, Russia countries also not using IPv6 directly. Okay, they are still using IPv4. If you have a network from Jio, then you may use IPv6 network in your communication. Okay, so that is like a private. You go to Germany or you go to Japan, you may use IPv6 in their public and private communications. Okay, guys. So in the IP address, it's a logical address and it is uniquely identify a device in the network. Already said IPv4, IPv6, two types. IPv4 is a 32-bit, IPv6 is 128-bit. IPv4 is developed and released very early than IPv6, and a lot of after research IPv6 is also released. So IPv4 is 32-bit, 2 to the power of 32. It is around 4.3 billion IP addresses. This is the exact number of this one. It is around 4 billion IP addresses. And here it is 2 to the power of 128. So 3.4 billions of IP addresses we are getting. It is like a 3.4 into 10 to the power of 38 IP addresses we are getting from IPv6. So IPv4 is a decimal format. So when you're writing an IP address, we don't write in a binary format, not in a 32-bit 01s. We don't write in a decimal format. and IPv4 is look like this one. And IPv6 is a hexadecimal format, and it is look like this one. Okay, so of course, so IPv4 is 32-bit. So we are writing this IP address into 4 parts. We are writing the total IP address into 4 parts. Means if you divide a 32-bit by 4, means you'll get a 8-bit. So this is called a octet. So each part of IP address, we call it as a octet, means each part is 8 bits, which is separated by dot. Some people still after learning IP address, and also a lot of people say point only. 192.168 point. It is not point, it is called dot. Okay. Point is different, dot is different. Okay. So here it is, each part is 8-bit. So 8-bit, 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 totally 32-bit. The 8-bit means it is called octet, meaning is 2 to the power of 8 is 256. The range of 256 means it is 0 to 255. Meaning is this is 8-bit, means the maximum value is 255, minimum value is 0. So each octet size is 0 to 255. So in IPv4, this each part maximum number is 255, not more than 255. Okay, so that's next. So these parts, I said each part is an octet. The first part we call it as a first octet, second octet, third octet, and fourth octet. Okay. Some people, for making more easy, they use W, X, Y, Z note. Like this is a W, this is X, Y, Z. So if you hear this kind of notation, so don't get confused. Okay, you can use ABCD kind of stuff also, but depends upon easy to understand. But originally we call the first one as a first octet, second octet, third octet, and fourth octet. Okay, next. So each octet, already I said octet means it is a 8-bit. So 2 to the power of 8 means 256. So if you write 0 to 255, it is 0 to 255. Okay. The each octet size is from 0 to 255. So it's not more than 255. The total IPv4 range is starting with a 0.0.0.0. Okay. And is a 255.255.255. If you start writing the numbers, okay. For example, yeah, you have to write numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you can keep writing, right? So it depends upon your decimals, right? Example, your mobile number, 10 digits, 10 digits. Earlier days we have a 9 series, 900 like that, 9 series is there, right? 10 digits, so start with a 9. So what you will write 90000000. 90001, 9002, 9003, like it will fill, right? And depends upon area. So that area related 9 series are there. Once 9 series is completed, then it is came with a 8 series. Now Geo using 6 series. Geo using 6 series, right? It is same here also. We are starting with a 0.0.0, and this last 0 is become 1, 2, 3, 4, 5. Finally we reach 0.0.0.254, and then it is reached 0.0.0255. Then it is become 0.0.1.0. Just like after 99, 100, right? 99 completed, 100. 199. 199. Next number is 200. 299. Next number is 300. Okay. 999. Next number is 1000. 199. 1999. Next number is 2000. It is same similarly only. So once 255 reach, it will become 0 and 1 is will be here. Again 1.1, 1.2, 1.3, 1.254, 1.255, then it become 2.0, 2.0 and 2.0, 2.1, 2.2, 2.3, finally it reaches 2.255, then 3.0. It goes on 0.0.255, 0.255. Dot 0.255, 255. So what will happen here? 0.1 dot 0.0.0. Once this is also completed, 0.255.255.255, then it becomes 1.0.0.0. So it keep goes like that. So it is also keep goes 255.255.255. So then what it is become 2.0.0.0. Finally, you can reach 255.255.255. This is the range. So we start with IP address from here. This is the last IP address, not more than this one. Guys, remember, no octet is more than 255, not even a single octet. Once octet is reached 255, it becomes 0. 1 will be added to the this part. Okay. So like this, it keep going. Okay. So what is the next one is I don't know what. So this is some example of IP address I written. I think so. So guys, here it is. Of course. See, this explanation I will come back. Okay. So this is the total IP address range from 0.0.0 to 255.255.255. Now what happened? This is totally 4.3 billion IP addresses. But we said IP address is a logical address. IP address we are assigning based on the size of network. Size of network means I have 100 computers in my network. So I need a related to 100 related IP addresses. In another network, I have a 500 PCs are there. 500 computers are there. I need a 500 IP addresses. Okay. So we can take it from here, but it is not logically division. All are IP addresses only. Where is the logical point? Logical means network and host. Logic means here.
Hello, sir. Sir, you
Network
are not
and
audible to me.
okay.
Hello. Hello, sir. You are not audible to me, sir.
Now can you check? Can you tell me? Are you able to hear? Can anybody tell me? Are you able to hear my voice?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, you are audible.
Okay. Um, disconnect.
Your voice is not coming properly, sir.
Okay. So where is the problem? We don't.
Your voice is clear. I think.
Sir, those people who face the problem, they can log out and then rejoin again. No?
Yes. So, guys, first test, speed test. I'll tell the thing first is do speed test. Speed is good. My problem is also there. How to close few things, but it didn't open much things also. Okay. My internet also problem. Please check once. Okay, so where are we in this scenario, right? So what we are discussing, we have a 4.3 billion IP addresses, and we are saying IP address is a logical address. So we have to use the IP address based on the network and host wise. We have to design it. That assign an IP address to the devices based on the network and host. Logically, we have to divide the network. So for example, I'm having a, guys, are you able to hear at least some people?
Yes, sir.
Yes, sir.
Very. Think like this, guys. These are all PCs are physically connected. So by this means we can understand these are all physically connected. Okay, physically connected. Then is it a logically connected? So what I want to do is I want to divide this network logically. Okay, so otherwise it is simple, right? So logically, physically single network, logically different network. Logically different network, like I want to do it. Meaning is their network address, for example, this PC network address is N1. Okay, network address must be same. Okay, and this network address must be same. Like this, different. Okay, so this is the network address. Next, host address. For example, host address is 1. This is host address is 2. Host address is 3. So why host address is changing? Because of that is the identification of device. Uniquely identify a device in the network, meaning is this one only. Network must be same, host is different. So then this is become single network. Even though they are all physically same network, but logically they become different network. Again, this is H1, like a host 1, host 2, host 3, okay, host 4. Meaning is different PCs, right? I have a PC1, PC2, PC3, PC4, PC5, PC6. So how we are putting a names on it and the numbering on it? Same way. The same way, this is all belongs to same network, right? For example, I have two offices, like office 1 and office 2. Okay, so office 1 and office 2. Put an area wise, for example, Pune office and Hyderabad office, and Noida office. So what I put for each device, I put some code like a Pune 1, P2, P3, P4. Meaning is if you see P, okay, it is belongs to Pune, and this is the sequence number, right? Item number 1, item number 2, item number 3, like this. Here in Hyderabad, I put a H1, H2, right? So H3, Noida N1, N2, N3. So you can see in my sequence also. See, for your batch, I put a N1. Okay, your previous batch, I put a N5, N4. Means these are all Noida batches. N4, Noida batches. This is my CTS batch, service desk. That's why I put as differently. I cannot put CTS per name, but I can change. Okay, so my previous videos you can try. Why it is not showing? Okay, see here it is. Some are like a batch 15, batch 17, batch 16. These are all CTS batches. Okay, so where are we? Okay, so similarly, network and host, even it is a same physical network, we divide the physical network into two logical networks, and the host address is different, network address is same. This is the main concept of logical addressing. To do that one, so we are dividing our total IP addresses. We are dividing all these total IP addresses into 5 classes. We are dividing total IP addresses from 0.0.0.0 to 255.255.255.255. The total range we divide into 5 classes. Class A, Class B, Class C, and Class D. Actually, is started like this, like a 8-bit number, right? This is the class A starting 0.0000000, and this is ending. First bit is we don't do anything. This is the so last batches I didn't told about this binary part. Here it is. The next number is 1. Like this is the binary number of 128. The first two will be like that. Remaining become ones. Okay, it's a class B, means second one, right? So first two. In class A, first 0 is like a 0 only, remaining become ones. In this one, so the first two will be like that, remaining become ones. Okay. The equivalent is 128.191. So why I didn't take in this? Okay, why I am not given these details earlier batches? Because first important is to remember remember these ranges, not this binary number. Okay, if you cannot able to remember the binary numbers, not at all a problem, guys. Okay, so in a class A, first bit is a will be remain like that, remaining become ones. In a class B, the first two become is not changing anything, remaining become all are ones. In a class C, first three bits are be like that, so remaining become all are ones. Okay, all are ones like this. Next, class D. Don't need to get confused, guys. It's a very simplest point. Okay, so how I'm getting this number? How I'm getting this number? That is also some people are thinking, right? This number is nothing but a next of this number, like a 99, 100 type. Okay, so this is the next number of this one. This is the next number of this one. Okay, so like that only. So we'll following sequence on. In this one, so class D, first four will be like that. All are 110 and remaining become ones only. So this is become 224 like this. Okay. This next number will be like this. No magic inside, it is just a numbering system only. Here in this one, all are become ones. Okay, so here it is divided into the entire IPv4 from 0.0.0.0 to 255.255.255. So entire IP addresses is divided into 5 classes: class A, class B, class C, class D. Okay, class A range is 0 to 127. I will tell what is this range also. Okay, class A range is 0 to 127. If you search in a Google, certain websites or certain textbooks will tell 1 to 126. Why? There is a reason. 0.0.0, this IP address is a reserved IP address. So we cannot assign 0.0.0.0 IP address to any adapter. We can't assign. We are using for a certain services like a default routing, DHCP, client server communication. That time we are using this 0.0.0. It is a reserved IP, and also we don't use starting with the 0 series. 0 series we are not using. We start with the 1 series only. 1.0.0.1 only we are using. So that is why the 0 is not there. So that's why we said it is 1 to 126. Then what happened to 127? What happened to 127? It is also reserved IP address. 127.0.0.1 is a reserved IP as a local host or a loopback address. Guys, every PC has a unique address, right? So this is having a 192.168.1.101. It's an IP address. So PCA having an IP address, PCB having an IP address, PCC having an IP address, PCD also having an IP address, PCE also having an IP address. You know, all these PCs having one more IP address, same IP address for itself. So for example, my name is Latif. But if I say like a myself, means it's me only. For me, I no need to call with my name, right? So that's very simple. So like that. So It's a self IP address will be there. It is not assigned to any adapter. Okay, it is not assigned to any adapter. We cannot use that one as a communication to outside. That IP address is 127.0.0.1. It is called a local host or a loopback IP address. Here I have written one example, guys. In a PCE, having some application. Example I have written is a Oracle DB application. Okay, I installed a Oracle database application. I'm using a client software called a SQL Plus. I'm using a client software called a SQL Plus. In this E only means where is a server application in EPC, Oracle database server application in the EPC only. And where is the client part is also in the EPC only. So the from client to this server is connecting using a 127.0.0.1 or name is a local host. Now, what is a local host is also there. Every PC has its own name, right? Every PC has a certain name. I put my PC as something like a PCB or maybe Office PC or Pune Office, like any name I will put it, or I will put my name only, right? So every PC, all these PCs having a name, PCA, PCB, PCD, PCE. But all PCs are having their self a common name called a local host. That local host IP address is 127.0.0.1. So when you are communicating, self-communicating means you have a PC and you have a server application. For example, it's a web application, web server, website, or maybe a Oracle site, or maybe it is a mails related one. And you are sending a request from your PC to your PC only, internally only, not externally, not from others to your PC to your PC only, you are communicating. So you can use, so you don't require any network connection. If you don't have any connection also, no problem. You have connected also, no problem. Okay, but you don't depend on any additional network. So because you are communicating internally, so you are using this IP address for a local communication within the PC, within the device only. We are using an IP address called 127.0.0.1. It is a reserved IP address for a local host or a loopback address. In this example, specifically, I have done like this. Look at here. So from in EPC, I'm using 127.0.0.1. But from APC, I want to connect it. From APC, this is APC. I want to connect APC to EPC. For this application, I want to access the database from APC. From APC, I want to access database in the EPC. Then what I have to use it? EPC IP address. I have to use EPC IP address, not 127, not a 127.0.0.1. So what I have to use it? I should open the client software. Okay, then put a IP address 127. So 192.168.1.137. This EPC IP address is 137, and give the username and then password. Okay, so that is, so for internal communication, we can use name, localhost, or IP address 127.0.0.1. For if anyone is communicating from outside, they should use your configured IP address only. Okay, guys, that is important. So this is a reserved, and also the 192.168. series 127 series is also we are not assigning. One more is there. It is 169.254.0.0 or that series entirely 169.254 series is a ABIPA address. So these ABIPAs we don't use for a communication. So obviously we don't use 169.254. So that is a separate part. Okay. So here it is. We are not using 0 series and 127 series. That's why in a certain textbooks, certain website they mention it is 1 to 126. And class B 128 to 191, class C 192 to 223, class D 224 to 239, and class E is 240 to 255. Okay, and a class E IP addresses we don't use it because class E entire range is reserved for some research and development or a certain places only it is using. We don't use for a regular communication, global communication or a private communication. We don't use E, only in a specific places. That too they use it, they put it a mark like it is R&D purpose only. Class D is a multicast addressing. Multicast IP address. So what is this multicast addressing? For example, I want to deploy an application to multiple machines. I want to deploy some application or an operating system to multiple PCs. Then I use a multicast addressing. It is simply multicast means like a WhatsApp group type only. So the group of PCs will get a certain information. So instead of sending uniquely one-to-one, I will send to a multiple group of PCs. So that is called a multicast addressing. Multicast addressing. Okay. So class A, class B, class C are unicast. What is a unicast? Unicast means one-to-one communication. Like you want to communicate from A. You want to communicate A to B. So then you use A source IP, B's as a destination IP will communicate. One-to-one communication. Unicast means one-to-one communication. A to C, B to C, C to A to D, D to B, B to D, D to E, E to C. These are all communications. So in a unicast address, you have a source IP and a destination IP address. It is we are sending a packet to one to another one only, not to one to many. Broadcast means one to all. Okay, one to all. Anyone is connected in the network. Multicast means only few people, multiple people, but it is a kind of following a particular protocol. Like 10 people I have to send. All are 10 are belongs to certain protocol. Like a EIGRP protocol, OSPF protocol, RIP version 2 protocol, deployment related protocols. So if they're following that protocol, then multiple pieces comes under single protocol. Okay, that is not everyone in the network. Broadcast means everyone in the network. Again, guys, class A, class B, class C is very important, and it is a unicast. We use class A, class B, class C IP addresses. But what is this class? how to identify IP address which is belongs to the class. Okay, which class it is. Already I said we have a octets. 4 octets are there, no? First octet, second octet, third octet, fourth octet. So first octet only, we have to check the first octet in the network in the IP address. First check the first octet. Okay, or in this sequence you can see W means first octet part. See the first octet and check the range of the first octet range. So then we can identify which class it is. See here it is 128.9.200.1. So first octet is 120. Remaining is don't worry about it. Okay. So first octet, look at only first octet, it is 120. 120 meaning is the range is class A. Okay. Yeah, you are already seen, but we'll try. Class 151. 151 is in the range of class B, right? So identify others. Which class it is? Which class it is? See, this is 224. 224 directly. So D.
Multicast.
Multicast IP address. 240. It is starting 240. It is class E. Just one more example. Just try that one. Which class it is?
Class B.
Very good. Class B. So we don't see these things, whatever it is, small number or big number. You have to always check first octet only. So based on that, we will understand. Okay, 170 is belongs to class B. Okay, so this is the IP address and their classes. But I missed few points in a IPv6 point kind of stuff. Okay, so we'll see that one also. So up to here, we'll see the next part. I'm going to explain what is this classes, subnet mask, network part, host part, ranges. Okay, and whether it will communicate each other or not, we will discuss. But important is something we miss here that not missing. Just I didn't continue that part. Okay. So that is about your IPv4, and we'll see the IPv6 also, guys. Small part only, just as like a once again. Okay, IPv4 is a 32-bit. IPv6 is 128. IPv6 2 to the power of 128, 3.4 into 10 to the power of 38. It means 3.4 billions of IP addresses. So what is a billion? Billion means 100 crores. Okay, so IPv4 still we are managing for entire world. Okay, so IPv6 we can worldwide we can use it like a multiple devices we can get it. Okay, so very big in size. It is represented in hexadecimal format. Hexadecimal format. Okay, so hexa means 4 binary bits. I think in this one only somewhere I have written the table. If you are not known, please check it. Guys, this is the decimal numbers 0 to 16. I have written 0, 1, 2, 3, 4, 5, 6 up to 9. As a single digit, it is a 0 to 9 single digit. After 9, again, it becomes double digit. Double digit in the sense it is, look at here. Again, it is repeat 1, 0, 1, 1, 1, 2, 1, 3. Once it is reached 1, 9, it becomes 2, 0. 2, 1, 2, 2, 2, 3, 2, 9, 3, 0. Okay, so the size of decimal is 10 from 0 to 9 only. But binary is 0 to 1 only. So once it is reached 0, 1, there is no 2, 3, 4. See, there are, those are all we have to write in a binary sequence 1, 0, 1, 1, 1, 1, 1, 0, 0, 1, 0, 1, like this. Next is hexadecimal. Hexadecimal size is from 0 to F. It is totally 0 to 50 numbers, means totally 16 single digits are there. Single digits are there. 0 to F, single digits are there. Okay. 0 to 60, so 15 means 16, total 16 digits are there. But they don't write in a numbers wise. 0 to 9. After 9, it is A, B, C, D, E, F. So that is a hexadecimal number. Next is a octal number. Octal number size up to 7. 0 to 7. 0 to 7. After 7, it becomes 1, 0. So there is no 8, 9. Okay. So what is the use of this octal and hexadecimal? So we can easily convert hexa-octal number into binary. That too directly we can able to convert it. Decimal numbers we cannot convert directly into the binary. So again we need a decimal to binary converter mechanism. That separate chipset is required. But it can be easily converted. So computer most friendly language is binary and instructions in the hexadecimal numbers. That's why we are using ASCII numbers, because there are hexadecimal numbers. Guys, if you see the last digits in the hexadecimal number is, in the binary it is 1111. It is also a last number in this format. Okay, in all 4 digits. Next one become 5 digits. This is 4 digits. This is 5 digits. In a binary way language, it is 4 bits. This is 5 bits. See, it is the 4 bits are from here to here. It is continue, and it once it is completed, then it is next. So that's why the maximum size of hexadecimal number is hexadigit. Okay, the number is 4 bits only. Okay, so that's the point here. Okay, just I want to finish that IPv6 and I will give you a break. Okay, but it is not complete. Okay, so that's why one hexadecimal is maximum size is 4 bit. So we can represent an hexadecimal in the 4 bit binary. So how many bits are there? 128 bits. So if you are writing in a hexadecimal format, so each hexadecimal is 4 bit. So 128 by 4, then it is 32 hexadecimals we use in a single IPv6 address. 32 numbers, hexa numbers we are using in a single decimal in a single IPv6 address. So that's a lot of people don't like it. Why? Because it's a very big in size. Okay, so 32 hexa, and these entire 32 hexadecimals are divided into blocks. blocks, and each 4 hexadecimals. Okay, 4 hexadecimals. In that one, they put a colon. For once 4 hexadecimal completed, they put a colon, 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 like this. So totally it is having a 8 blocks. Very simply say 8 blocks. Each block contains 4 hexadecimals. It is divided by colon. Okay, so this is a IPv6 format. In IPv6, different ways to write a IPv6 address. If you see here, it is 2001 double colon A. Meaning is this is the original format. Means it's a complete format is look like this one. Okay, this is the small number, but this is the same thing. Both are same. Colon colon means in between there is a zeros. Instead of writing a zero separately, you'll write it. And also I have given this example, guys. So what you will do it, so if you have a time, then copy all these things into your notepad, see it clearly how it is compressed, how it is written, how it is and should not be written like that it is there. So try that one. Okay. And IPv6 got a small break at this point, but it will continue here. Okay, in IPv6 also we have a local host and loopback address. Like in IPv4 we have 127.0.0.1. In IPv6 it is showing like a colon colon 1. This is IPv4. This is IPv6 for a local host or loopback address. Okay, and also as I said, some unknown IP address kind of stuff or some reserved IP address for a certain default routing and DORA process related one is there, that is called a 0.0.0.1. In IPv6 that represented in colon. That represented in colon. Okay. Next, in IPv4 we have a unicast, multicast and broadcast type of communication. In IPv6 you have unicast, multicast IP addresses and anycast IP addresses are there. Okay, anycast type of communication, multicast type of communication, unicast type of communication is there. Okay, and every adapter, your IPv6 is enabled on your adapter. Every adapter has its own IP address. Itself self IP address is there called a link local IP address. Link local IP address. Okay, link local IP address. Okay, FE80. When you see an IP address with FE80, it is a link local IP address. It's a more unique IP address because of that starting FE80 is a common and colon colon. That's it. Remaining part of IP address is from MAC address of NIC. From MAC address of NIC. Okay, so it is a more unique IP address. It is a link local, and in a network, you connected 10 computers in the network, and if you don't assign any IP address, you don't have a DHCP server, you don't assign any IP address, only you are enabled IPv6. We can communicate each other using IPv6. Using IPv6, we can able to communicate each other even though you don't have any DHCP server or you didn't assign any IP address to your PCs. Or to communicate in the local, we can communicate using link local IP address. Okay, it is a private IP, cannot be routable in public. And there is a different type of IP addresses are there. So link local IP address, private IP, multicast IP addresses, global unicast IP addresses also there. Global unicast IP address is public IP address. The starting range is global unicast is 2000 colon, like that it will come. The first part, okay, 2000 means it is first part, heading part of your IP address, okay, IPv6 address, and maximum size is 3FFF. Plus global unicast IP addresses, and most of the private IP, public IP are take care by your ISP providers kind of stuff. But link local IP address is generated by your PC only based on your PC's MAC address. So this is the MAC address. This is my link local IPv6 address. This IP address is valid and we can communicate with this IP address in the local LAN, in the LAN only, not WAN communication. Okay. That's it about your IPv4 and IPv6. So some basic information. Let's take a break, come back in a 10 to 15 minutes. So we'll continue this IP addresses. Okay, and what is network, what is default gateway, sizes, private IP addresses, how to check both systems are communicating each other or not, what is subnet mask, what is subnetting. Okay, so any other things, NatPat kind of stuff also we'll see. I'm stop recording.